Find the point of contact Q of the tangent 4x plus 3y plus 13 equals 0 to the circle x squared plus y squared minus 6x minus 16 equals 0. Here is a graph of the line. Let's see a graph of the circle. Now the circle here is given in the form x minus h squared plus y minus k squared equals r squared. Let's look at the point or points of intersection of the line and the circle. Indeed, there's only one point, so the line is a tangent to the circle as stated in the question. Okay, the point of contact is actually minus 1, minus 3. Okay, we've covered this in algebra. We want to solve between a linear equation and a nonlinear equation. So you'll see how to do this in the section on simultaneous equations, where one equation is linear and the other equation is nonlinear. We take the linear equation and we rewrite it so that either x or y is the subject of it. I'll make x the subject of this equation. So to do that, we bring the 3y plus 13 over to the other side. We get minus 3y minus 13 and we divide across by 4. Next we substitute this into the nonlinear equation. It's a circle in this case. So we just replace x with this, and we've done all this before, so I'll quickly go through. We have to expand this out. Okay, that's what we get for this term. We have to multiply minus 6 over 4 by minus 3y minus 13. We can simplify this a little bit. So we multiply minus 3 into minus 3y minus 13. That's plus 9y plus 39. That's divided by 2. Now I will multiply all of this equation by 16 to get rid of the denominators. Now when we multiply 16 by this fraction here, we have 16 divided by 2, which is 8, so we have 8 into 9y plus 39. So 8 times 9 is 72. And then we have 8 times 39, that's 312. Okay, so 16 multiplied by this will give us 8 times 9y plus 39. Finally we have 16 times 16. So we get minus 256. 16 times 0 is 0. Simplifying, we get this here. We can divide all of this by 25. 25 times 2 is 50. 3 50s is 150, so we get 6 here. And we've 8 and 1, that's 9 25s here. Now we know that since we are told that the line is a tangent to the circle, it must be the case that the two factors of this equation are the same. The factors of y squared are y times y, so we know that these two numbers must be identical. We can't have minus 3 by minus 3, so we must have plus 3 by plus 3. So, you know, you put each factor in turn equal to 0. Well, the factors are the same, so we get just one solution, y equals 3. Or sorry, minus 3. Okay, so that's y. How do we find x? Well, we go to the linear equation, which was x equals minus 3y minus 13 divided by 4, and we just plug minus 3 in for y. So we get plus 9 minus 13, that's minus 4 divided by plus 4 is minus 1. So x is minus 1, y is minus 3. So the coordinates of the point of contact, as we've seen before, are minus 1, minus 3. Find the distance from the centre to a chord of length 8. So how do we get the centre of this circle? Well, we compare the circle to the general form of a circle. This is the expanded form now. And as we've seen before, h is got by halving the coefficient of x and changing the sign. So h is plus 3, minus 2k equals 0, so k must equal 0. So we just put minus 2h equal to minus 6, and we solve that to get h equals plus 3. So the centre has coordinates 3, 0. We can get the radius using this formula here. So h is 3, k is 0. Now c is the constant term. C in this case is minus 16. So we have minus 16. That gives plus 16. So as you can see from this, we get root 9 plus 16. That's the familiar, you know, it's root 25, which is 5. So we're interested in chords of length 8. let's suppose that that's one of the chords. We know now that the radius of the circle is 5, so the distance from the center of the circle to the endpoints of the chord is 5. Now we want the distance of the center of the circle to the chord. So we want this distance here, the perpendicular distance of the center to the chord. Now this is where we use a theorem that was proven in an earlier video. If the line drawn from the center of a circle perpendicular to any chord of the circle bisects the chord, so it cuts it in half, so that distance from here to here is the same as the distance from here to here. So this distance here must be 4, and of course this distance here is also 4. But now we see that we have a right angle triangle formed here. Actually, this is the most famous right angle triangle. The hypotenuse is 5, one of the short sides is 4, so we know straight away that the other short side is 3. Of course, if it doesn't come up like that, we can easily solve it. We call this distance d, then we know that d squared plus 4 squared equals 5 squared. And we can solve for d, and if we do that we get d equals 3. Next, we need to find the slopes of two chords through point Q, which cut off chords of length 8 on this circle. So Q, remember, was the point of contact of the circle to the tangent. Q has coordinates -1, -3. So basically we want to find the slopes of these two lines. Now here is one such chord that passes through the point Q. Its length is 6.3. Of course we want its length to be 8. To get the slopes of these two chords, we get the slope of the line joining the center to this point here. The slope of this line here is straightforward to get because we have 2 points on it. So we just get rise over run, this distance divided by this distance here. And we already know that this is 3, and this distance is half the length of the chord, which is 4. So the slope of this line is 3/4. Now let theta be the angle between this line and this chord here. Now it's actually the same as this angle here. This is also theta. That's because the point 3, 0 is equidistant from the two chords. The distance of this point from the two chords is equal to 3. That's the perpendicular distance. And if a point is equidistant from the arms of an angle, then the point is on the bisector of the angle formed between the two chords. So this black line here is the bisector of the angle between the two chords. So these two angles are the same. Now probably the most straightforward way to do this question is to use this formula here. This formula relates the tan of an angle between two lines to the slopes of the two lines. So I'll call the slope of this black line M1. And the slope of this red line M2. We know that what the tan of theta actually is. We saw it from the construction. Tan of theta opposite over adjacent is 3/4. Now we get two answers for the slope depending on whether we take plus or minus this quantity here. So I'll start by taking this equation with the positive sign. M1 is 3/4, M2 is what we don't know. We can cross multiply here. We have one fraction on each side. 3 times the denominator here will give you 3 plus 9/4 M2. 4 times the numerator will give 3 minus 4 M2. If we bring all the M2s to one side, we get 4 plus 9/4 M2. That gives 6 1/4 M2 on the left hand side, and bring the 3 over, we get 0. Actually these just cancel out, so we see that M2 must be 0. And as you can see from the picture, this line is a horizontal line, so we've got the slope of this chord here. Now by taking the minus sign, we will actually get the slope of the other chord. So we cross multiply. I'll take the minus sign into the numerator. So I'll multiply 3 by the denominator. That'll give 3 plus 9 quarters m2. Now I take the minus sign into the numerator, so we 4 times minus 3 quarters, that's minus 3, and then we 4 times plus m2, that's plus 4m2. Solving this equation, we get m2 equals 28 over 7. I'm sorry, this should be 24 divided by 7. I've checked this. Now if you know nothing about this formula, you could still do this question by considering the angle that this black line makes with the positive x-axis. Well, we know the slope is 3/4, so you could actually work out this angle. The tan of this angle here is equal to the slope. So this angle is inverse tan of 3/4. So that's what we know about the slope of a line. We always measure anti-clockwise from the positive x-axis to get this angle. We could then get angle theta from the construction, because we know we have a right angle triangle here, and we know that this angle is inverse tan 3/4. Now these happen to be the same, but of course in general they don't have to be the same. Now to get the slope of the chord, we need to find the angle between the chord and the positive x-axis. So basically we would just consider these two angles. Like if the chord wasn't horizontal like it is here, say it looks like this, then it cuts the x-axis and makes an angle with the x-axis. And to get the slope of the chord, we would have to get the tan of this angle. But if we know this angle here and this angle here, which we do know, actually, we know these two angles, then we can actually find this angle here. It's actually a matter of just subtracting. We just take this angle and subtract this angle. That's actually how we derive this formula, but you could still work it out. You could get the angle the chord makes with the x-axis. You'll find that as 0. If you take this angle here and subtract this angle, you get 0. To find the slope of this line here, you will need to get this angle. You'll find that this angle is actually the sum of these two angles. That's inverse tan 3/4 plus inverse tan 3/4. So this angle is 2 inverse tan 3/4. So you can plug this into your calculator, get this angle, and once you know this angle, get the tan of it, and the tan of it will be 24 over 7.